Hello students, welcome to MyAbhyas. My name is MyAbhyas and I am your physics educator. So we have studied from the last sessions about electricity, okay, and I have a suggestion for you people to just go around it once, just have a glance about it once before going to this session, because this session is very important and it is a continuity. So but at the last I'll be briefing you everything once again. So coming to the today's session, what are we going to study? So if we have a goal, then we have to reach it, right? So today's goal is we'll be doing some topics which are very important, and these are compulsory questions, you can say, for your exams, academic exams. So coming to the first topic, what we'll be studying here is we'll be studying resistors in parallel, resistors connected in parallel. So next, after this, we'll be giving you some numerical problems to show the applications how the resistors in parallel take place. That is, how the resistors when they are placed. Okay, how can you solve using the formula of resistors in parallel? So coming to the second point, we use the numerical problems based on resistors in parallel. So this is numerical problems. After that, I'll be giving you the introduction about heating effects of electric current. Okay, so it is heating effects of electric current. So these things we'll be learning today, and this heating effect of electric current, I'll be just giving you the introduction so that we can derive there is a derivation on this topic. We'll derive the equation tomorrow, but the introduction and the explanation I'll be giving it today. So coming to the first topic today, we have resistors in series. So we have, resistors in parallel. So we have this, right, resistors in series. We have found out the equation for that. And the equation was what? Rs is equal to, or R equivalent is equal to what? R1 plus R2 plus R3. Where is this? In series combination. And we have noted that in series combination, what happens is the voltage is divided, okay, but the current is same. That is, I is same. Voltage is divided, you can say, right? Okay. So now coming to the resistors in parallel. So I'll be drawing a circuit here, and please concentrate how to draw it so that you cannot, you can be used to it. Okay. First, anyways, battery will be there, like as usual, battery. Then you have a key, okay, and then a ammeter. So you can take the ammeter at the side also, but you can take it here also, not an issue. So coming to this plus and minus, and this is key, this is battery, and here you have minus and plus. After this, I will be taking the circuit up, and then so here in the last session I had said you that in parallel what happens is like when you take parallel roads, okay, so if this is a main road, then these are parallel roads. How are they? They are exactly they are exactly parallel to each other. Clear? So that's why we say a parallel combination, like a branch, you can say branch. So after this, it will be again divided into three. That is, I am considering R1, R2 and R3 resistors. So this is R1, R2 and R3. So again, this I will be connecting it. Okay. So after this, I'll connect this here. So this is the circuit diagram, and naming you have to do it, very important. So this is, if I take X end and this is Y, then here current divides. So current divides into Y because as it is going, it has three branches, right? So current obviously goes to all the paths. So it will be I1, I2 and I3. Next, what I'll do, I'll just attach a voltmeter here so that I can understand what is the potential difference there. What is the voltage when the current is moving in those resistors. Next, coming to R1, R2 and R3. Okay, so this is my circuit connection. I'll explain you once again. So coming to the first one, draw a battery. After that, a key and an ammeter. After that, connect it to the parallel combination of resistors. So when you connect it to the parallel combination of resistors, what happens? You have to parallelly connect a voltmeter which measures the voltage. After that, that will be again connected to the ammeter of positive potential. So now what I have to do is I have to derive the effective resistance for this. Okay, I have to get to know R1, R2 and R3 should be like effective resistor I have to take. So now what I'll do is, in the first case, I know that here the current is getting divided into I1, I2 and I3. So I'll just take it. That is the total current. Okay, the total current passing through the circuit is equal to what? I1 plus I2 plus I3. Okay, so from Ohm's law, what do I have? V is equal to IR. Or for I, what I can say? I is equal to V by R. So here I am finding out for parallel. So I will be taking P everywhere. Okay. So next, now I want the value of I1, I want the value of I2 and I want the value of I3. So similarly here from this equation, I can write the value of I1, I2 and I3. Right. So I1 is equal to what? V by R1. I2 is equal to V by R2 and I3 is equal to what? V by R3. Clear? So this is from what? This is from Ohm's law. Okay, next. These three, that is 1, 2 and 3, I1, I2 and I3 and this IP. Okay, so IP is equal to I1 plus I2 plus I3 and this IP, I'll just take this equation and this is, I'll just take first, this is first one, second one and 3. So I'll substitute equation 2 and equation 3 in 1. So what do I get is V divided by RP is equal to V by R1 plus V by R2 plus V by R3. Clear? From here this is, okay, from the first. Next, V is, you can take V as common in this case and then V gets deleted or scratched. So that is V into 1 by RP I will take, if you can write it, or V 1 by R1 plus 1 by R2 plus 1 by R3. So V goes, what remains? 1 by RP is equal to 1 by R1 plus 1 by R2 plus 1 by R3. So this is the equation for resistors in parallel combination. So first thing what you have to remember is, in series combination the current is the same and the voltage divides, but in parallel combination what happens is the current divides but the voltage remains the same. So this is how you have to solve. I just tell you once again. So in the first case what happens, whenever I see the circuit, I get to know that whenever the current is moving, then the current is getting divided into 3, that is I1, I2 and I3, because I have considered only 3 resistors, R1, R2 and R3. After that, when the current is divided, I have to find out the total current there, like what is the current for the whole combination. So IP is equal to what? I1 plus I2 plus I3. So from Ohm's law, what do I have? V is equal to IR. So after that, from that equation, I'll just take the value of I. So I will be equal to what? V by RP. Next, this IP, I'll be substituting, and then I'll similarly from this Ohm's law derivation, I'll be taking it for all the currents, that is I1, I2 and I3. I1 is equal to V by R1, I2 is equal to V by R2 and I3 is equal to V by R3. So after this, we'll be just placing it in the first equation, and that will be V by RP is equal to V by R1 plus V by R2 plus V by R3. So V cancels and I get the result as 1 by RP or 1 R effective, you can say, that is effective resistance. 1 by RP is equal to 1 by R1 plus 1 by R2 plus 1 by R3. So this equation gives you the equivalent resistance whenever the resistors are placed in parallel. So now we'll solve the numerical based on the resistors in parallel combination. So series we have done, now parallel we'll do. In the circuit diagram, so I have kept the same circuit here. So in the circuit diagram, suppose the resistors R1, R2 and R3 have the values of 5 ohm, 10 ohm and 13 ohm. So R1 has 5 ohm, R2 has 10 ohms and R3 has how much? 30 ohm, okay, respectively, which have been connected to a battery of 12 volts. So that is connected to a potential difference of the battery, which has of the value of that is 12 volts. So coming to the thing, what we have to find out, they have given. So I have written it here for simplicity's sake, like before, like after the circuit diagram only, you will get to know what to find out. So calculate A, the current through the each resistor. So current through the each resistor I have to find out. After that, the total current in the circuit, total complete current, how much is passing, I1, I2 and I3 together I have to find out. And then the total circuit resistance, that is R, I have to find out. R in the sense what? RP I have to find out. So coming to the next, first thing, I have to calculate the current through each resistor. So first we will write whatever they have given us. Solution. So what is the solution? Solution is first thing, data I have to write. What is the data? R1 is how much? They have given me R1 as 5 ohm and R2 as how much? 10 ohm, R3 as 30 ohms. And what about the battery voltage? V is equal to 12 volts they have given. So coming to the first A, I have to find out the current through the each resistor. So we know that the current through each resistor will be equal to what? That is V by R1 plus V by R2. So I1 is equal to what? So when I take here I1, so I1 is equal to what? V divided by R1. So that is V by R1. So what is the value of V? The value of V we have is 12 volts. And what is the value of R1? We have it as 5 ohm. So that will be equal to how much? It will be 2.4 amperes. Clear? After this, second one, I2 I have to find out. So that will be V divided by R2. And that is equal to 12 volts divided by, I have 10 ohm. So that will be 1.2 amperes. Next is C, I3 is equal to what? V divided by R3. And that will be equal to 12 volt divided by 30 ohms I have. And the answer for this will be 0.4 amperes. Okay, approximately 0.4 amperes will be the current of I3. So I1 plus I2 plus I3, this thing is done. The current through each resistor is, through R1 it is 2.4, through R2 it is 1.2 and through R3 it is 0.4 amperes. Now coming to the total current in the circuit. So total current, how do you find out? Just take I is equal to what? I1 plus I2 plus I3. So I is equal to, what is the value of I1? 2.4. What is the value of I2? 1.2. And what is the value of I3? 0.4. And that will be equal to, I will be completely equal to how much? It is 2, 3, so 4, 5, 6, 7, 8. Okay, it is 4 ohms. Okay, 4 amperes you can say, 4 amperes it is. I is equal to 4 amperes. That is the total current. So after this, what I have to find out? Second one we have done. First one is done. Second one is done. The total circuit resistance, total the parallel combination RP, 1 by RP is equal to what? 1 by R1 plus 1 by R2 plus 1 by R3. So that will be equal to, what is the value of R1? 1 by 5, R2 is 1 by 10 and R3 is equal to 1 by 30. So all together, when I take the LCM and when I divide it, I get around 1 by 3. That is 1 by RP is equal to. So from this relation, what I can say, the RP value is equal to how much? 3 ohms. Clear? So this is how you have to solve the equations and you have to apply the formulas. So I have said you the trick. The trick is you have to get to know what they have asked, okay, and how do you apply the formula. So we'll look into the next question, and this is very interesting and also it is very important. So this type of questions, they may ask you to confuse you. So coming to the second question, in the figure, so I have drawn the circuit which they have given.